This question here focuses on triangles and the area of triangles using angles and sine within it. Now in this diagram, we're told that AC is perpendicular to BC, AB is given a length, BD is given a length, and BC is given a length as in the diagram there. Now we're told the angle of the triangle ADE is 160 square centimetres, and I want to calculate the length of AE. Now instantly our brain would maybe go to sine rule or cosine rule or SOHCAHTOA or something like that. The issue is we're missing angles. However, we're asked as well for the area of a triangle. Now normally area of a triangle, half times base times the height. However, in this case we don't have the height. Remember, height is the perpendicular distance, or would be, from D to there. So we don't have that one. But we do have another option for the area of a triangle. And the A equals a half BC sine A. That's the other option we've got. Now, if it wants the length of A to E, so this entire length here, let's imagine I were to take that, and I was thinking about this formula here, and I labelled that as B. If I then imagined that whole side there was my C in that formula, that corner there would be the A for the sine A. So I'd actually have dimensions I could use in order to be able to calculate the area, which I'm actually given. So I'd have information in there except the side A to E, which is what I'd be after. So I could manipulate it and solve it in that manner. The first thing that we need to do is figure out sine A. Now if you look at this little bit here, where the triangle ABC is, if I was to draw the triangle ABC, so A, B, C, and mark on the information that's there that's relevant to it, I'd have 18 and I'd have 8. But what I also have is right angled. And I'm not assuming that, I'm told that in the diagram. So that's a right angled triangle with two sides. So I could calculate from that a third side, or I could calculate the sine and the cosine and the tangent of any of the angles after I've done that as well. Well, the formula for the area of a triangle needs sine A. So I can get sine A using SOHCAHTOA here. Because I know SOHCAHTOA tells me that sine is the opposite over the hypotenuse. Now there's my angle A is marked on. The opposite is 8 and the hypotenuse is 18. So what that tells me is that sine A is equal to 8 over 18. Now in that right angled triangle that's true. However, looking at the original diagram, that right angled triangle is actually part of the bigger picture of the entire triangle. So sine A equals 8 over 18 for the little right angled triangle here actually holds for the big triangle ADE as well. So what that means is I've actually got that part of my formula, the sine A. I also have the C, which is the length of that side, the side AD, and I also have the area. So I actually have all the information for that except one variable, which means if I put that information in, I can solve for that variable. So if I construct it all together with the information that I know, I could write that 160 is equal to a half times B. Now B is the side A to E, times C. Now C is the entire length ADE, so it's not just 18, it's actually 18 plus 6, so it's 24. And then it's going to be times the sine of A. Now I know sine of A is 8 over 18. So it's times 8 over 18, just like that. So I've actually come up with some sort of relationship for it that I can now manipulate and use. If I simplify this right-hand side, what I'll end up getting is that 160 equals AE times, well, if I have a half of 24, that's 12. I've then got 8 12s, which is 96. So I'll end up with 96 over 18. So if I were to take that and manipulate it and move it around to get rid of this fraction, so remember 96 over 18 means times 96 divided by 18. So when I flip it, I'll change the multiplication and the division. I could write that AE is then 160 times 18 divided by 96. Just from manipulating that information and those numbers that's gone in. And what that'll tell me, once I do it, is that the AE, that side, is equal to 30 centimetres. That's what I get as my final answer to that one. So I've calculated the length of the side using that area formula and the relationship between the two triangles, where one of them is actually part of the bigger triangle. It's actually a wee subsection of it, but then the sign for it applies to the whole thing. So it requires a little bit of thinking, this one, and a little bit of logic, but it is one of those questions that once we start to get the information, we start to build up and realize what we need and how we use it, we can actually plow our way through it and get to it. Now, this question here is worth 4 marks on its own. First mark is for getting your sine A is 8 over 18. Your second mark is for the half AE times 24 times 8 over 18. And then your third mark is for setting it equal to 160. Now you can actually get 2 and 3 from just writing the statement I have done there. Rather than writing them 2 separate statements, if you write it just as that one statement, you'll get both marks for it then. Then manipulate, work it through, get your numbers, and getting that your AE is 30 centimetres, that would be your final answer and your final mark there. So it does require a bit of thinking, does require a bit of logic in this one. It's not the most straightforward, purely because, again, like I say, the triangle relationship to one another and recognising the area formula you've got. Again, hint, hint, that area formula is in the formula list. But it is doable once we make sure we have the right dimensions, we have the right sides, and we have the right information that we're working with, and that we can ultimately manipulate it properly. If you can do that, you will be able to smash this question. Once you smash the question, you'll realise it's fairly straightforward, easy peasy, lemon squeezy.